Okay, so first I'm going to be opening up a new Jupyter session on my laptop. I will also be putting in the pandas code, pandas, NumPy, Seaborn, and matplotlib into my imports. Go ahead and put that in. Everything is running well. Then I'm going to be taking my file directory into there for the file that I downloaded from the cdc.gov site. I had information for COVID-19 and from the beginning all the way to current time. As you can see, I had edited it down to what I needed for my project, and I have it down to date, total cases, total new cases, deaths, ICU patients, positive rates, total vaccines, new vaccines, vaccinations. So I'm going to use that into this. Okay. Now I'm going to put the data up. As you can see, like I mentioned, this is the same spreadsheet that I had opened up earlier right here from the CSV file, and then as you can see, it has all the other columns that you saw on that file. You do notice that they have an NAN, which we're gonna later on just ignore for when we get a little bit further down the road. But for now, we could work with this. The next step, we're going to look at the actual data head of this file. And you'll see that gave me the first few lines of the CSV file. We could do the same thing for the end. Type this in, or we get the last few lines as well. You can see that there's a stark difference from where we were in 2020 till now. It's a big difference as far as cases and total vaccinations. The next thing that we're going to talk about here is looking at just at the columns of the CSV file. So you can see right here, we're going to be using these, or at least some of these, to show our plots. Next, we're going to do a plot. So we're going to put in real plot. Just bear with me here. X equals total cases, comma, Y will equal total vaccinations, and data will equal data. There we go. Oh. As you see, you make one spelling mistake and you'll get an error. This is easy to fix though, so we'll just put real plot, what I meant to put in. Now it's going to just think about it and give me a plot. Now this is something that I've expected. The total cases of corona has gone down with the introduction of total vaccines. This still looks a little not just plain, but not as visually appealing to what we would like. So what we're going to do is try a different kind of plots to see if it'll be a little bit better. Alright, so what we're going to put in is FNF cat plot, and we might as well just copy the data that we have here. Take out that extra. And you know what? We're going to put in new cases for X. New cases and new vaccines. Let's see what that gives us. Takes a little while for it to load, so you'll see that the little hourglass comes up. So this should come up. What we're expecting here is basically to be similar to this, where we see the cases of new corona cases going down, hopefully with the introduction of new vaccines being implemented. So it's coming now. You'll see the little out 12. I'll fast forward this. So there we go. So that looks good right there. You see a little bit of a difference there, and actually looks a little more visually appealing. We also notice that, again, with the new cases, with new vaccines, it seems to be going down there. So that's a good sign. Okay, so what we're going to do here is use the same plot, but just add in something new just to give us a little bit more of a definition for this graph. What we're going to do here is add in hue, and we're going to put in total vaccinations. We're also going to update this to total cases and this to new cases. Okay. Instead of cat, we're actually going to be using little plots. Alright, so this should kick back. Yep, and it's thinking. So with a little bit of time, that's pretty quick. You're going to get back a graph, hopefully a little bit more defined. And what do we have? Yes, we're starting off with total vaccinations in the red, then going all the way down to a hot pink, even hotter. And this is our graph. And as you see, when we started with less vaccinations, we had a higher number of cases. Where we have a lot more vaccines being implemented, we have a lot less new cases. So this is a good way of showing that vaccinations are actually helpful to fighting coronavirus. This is a good news for us. It looks like, it's a good way to show, again, the good benefits of vaccinations and what it's doing for getting everybody back on the road. Now that we have a little more of the detail, let's try out some new plots and let's see what we can get back. Again, what I'll do is I will take this code, change the hue to total deaths, and we're going to keep total cases and new cases as the X and Y. We'll run that, and it's much quicker. And as you can see, yeah, that pretty much represents what we've been dealing with since the beginning of the pandemic. Unfortunately, it's really sad, but you see the amount of deaths that we had in cases. So you see the cases gone up, and unfortunately, that death toll is really high. So the good part about this is it's coming back down, and hopefully we could fight off this virus as we see right here in our graph above, given that we go take our vaccinations. What I'm interested in seeing is we take the same plot and just tweak it a bit, because right now we have total cases, but we also want to see from the beginning of time since we've had this issue. So let's run this code again. And it's digging in there to find out more information. So you gotta bear with me. Oh, there we go. It has something for us. It's gonna come any moment. Okay, here we go. So we have basically the same graph. It's a little bit more compact, you see there, just because we have more time to deal with. Then you see as above, it lists the amounts of new cases that we had, the total of deaths. You can see the color scheme there to give you a clearer picture of, how it's done from, how we had from the beginning, 0 deaths all the way to over 500,000 deaths. So, the next one that we're gonna do. So, like I said, the next one we're gonna do is same graph. However, again, we're going to change our x's and y's. In this case, we're going to change the x to total cases. and our Y to new deaths, and our hue is going to actually be positive rates of infection. Okay. Oh, what did I do here? Alright, so I just have to fix my spelling. Okay, here we go. So this graph kind of tells a story on its own. So you see the total amount of cases that we had, with the total of new deaths that had arrived with the positive rate of infection. You can see that more infections, more deaths, less infections, less deaths, more, less. So this is a good way of seeing visually, at least, the effects of how Corona affected us, death-wise, total-wise. There are now, unfortunately, there are some other kind of graphs that you would look at and you would guess that aren't as helpful. Let me see if I could bring that up for you. Okay, so what we're going to do is actually take a new graph, see if vaccines had an effect on the positive rate of infection. What we're going to put in here is total vaccination. Our Y is going to change to positive rate. We're going to change from hue to actually line graph. So let's put line. And that should give us a nice graph to look at. Or maybe not. Let's see. So, I mean, as you can see, it does infer that positive cases have went down with the total of vaccinations being distributed. But as far as somebody reading it, they might look at this and say, no, not something that is visually appealing. But you can still make out what it's trying to give to you. Now, if we're trying to look at several different plots at the same time, we could actually do a pair plot of the data that we have. And this one's going to take some time. Just bear with us a sec. It's going to take a little bit of time. I'll make sure to edit this. Oh, there we go. Here we go. So, as you can see, there's different graphs. Some that are useful. New vaccinations, positive rate going down, as you see. Same thing with hospital patients, ICU patients. So vaccines are proving to actually be helping here. New deaths are going down. So this is a good way of seeing different plots, and sometimes what actually makes sense. And if you want, you can see which ones take interest and go into a little bit deeper. All right. Okay, so what I'm going to do right here is switch over to our studio. We have a new screen and session. First start off with getting the file over. So copy that. Okay. First, I want to view my data. There you go. As you can see, I reduced it down to what I needed for this, and the majority is just for total cases, new cases, and total deaths. All right, I'm gonna get results back using k-means. As stated before, we're also gonna omit those NAs, those empty fields that we had from the data that we retrieved back from the CDC. And we're going to use 3 clusters. All right, we're going to review the results. And as you see, 3 clusters have 3 sizes, 121, 68, 246. Here's the means for the 3 clusters. Total cases, new cases, total deaths. We have vectors over here. Then we also have some other results that we could get. So we'll go down and we'll see this results. And we want to look at sensors. Those are the sensors for the clusters. Okay. And now we want to do is actually get a plot for the k-means that we just ran. So total cases. New cases. This is our X and our Y. Results as far as our color scheme. And we're going to use the cluster. Okay. And here you go. So what we have here represents the clusters, the 3 of them. So you see the red, black, and green. Let's see, this is again total cases with new cases, and it's similar to what we saw in the other plots that we had. All right. Now we're going to try a different plot, similar. We're just changing around the cases again. Not the X and Y, my apologies. So total cases. Let's try total deaths. Okay. Now this is a much clearer one. You see a line, and it gives us again these 3 clusters with a little variation at the end. Alright, let's try another plot. Just changing around the X, Y's. Let's try deaths and total cases. So again, you have a bit of the same that we had before there. Alright, so let's try switching around our X's and Y's. Some cases, and let's do new cases. So new cases, total cases. There we go. It's on similar as the plot that we had before when we first started there, and then as you can see again, we have 3 different clusters and they're arranged a little differently. What we're going to do is change our Y. See if there's any difference. Again, it's almost the same kind of layout. Again, that's because we changed our X and Y's. Alright, so what we're going to do from here is change the amount of clusters that we actually have. So let's change our clusters. Let's see, from 3 to 2. And I want to see our results. and they will be different. So what you'll see is that the sizes change, the means change, the vectors change, and you can see that from the top. You could also even look at some of the results. And let's see, we want to do what we had before was size. Again, size is different. Do sensors. Sensors are different. 268, 268, 10567. Oh, the sensors, those are sensors from before. So there we go. 287, 878. Let's see, different sensors. Alright. Now what we want to do is check our plots. See what kind of different plots we have. The last one that we looked at was new cases. Total cases. Let's try total cases. Total cases and new cases. So look at that. We have two clusters and two color schemes, as you see from before. We'll try one more. Yeah, again, we have just two clusters this time, but it's giving back this almost a cylinder plot that we had from before.